Good morning, everyone. So my name is Piergiorgio Ladisa from Cybersecurity Research and University of Rennes, and today I'm going to present our work named SoK Taxonomy of Attacks on Open Source Software Supply Chains. Right. Before understanding what are the common attacks on the software supply chain, on the open source software supply chain, we first wanted to understand how it is composed, the software supply chain, and namely what are the systems, the roles, and the interaction to understand where the possible threats can be. So the way in which commonly open source software is built, everything starts with a versioning control system where the source code is stored and available, and where project contributors can submit their proposal for changes to the software via merge request. And then we have project maintainers that typically administers the entire project, and then they can review these changes and accept them or refuse them. And then the source code is cloned into the build system to then be built, and so to have at the end of the chain a pre-built version of the software that is then hosted on common distribution channels like package repositories like PyPy and NPM. And this is because to make easier for consumers to consume the software. Consumers can also directly consume the source code and then build on their own. And what I wanted to highlight is that this is just a simplification and a generalization of how the supply chains are. And the attack surface can increase a lot if we think about that this model can be replicated for each project that we consume, especially in the dependency tree of our application. Right. So what is, or what we intend as a software supply chain attack? We intend those attacks that aims at injecting malicious code into software components as an aim to spread malware and compromise downstream users. And in the specific instance of open source software supply chain attacks, these leverage the widespread adoption of open source software along the whole technology stack. But what we wanted to understand is how these attacks are characterized. And what we observe is that recently different attacks started appearing and being discussed in medias. And the thing is, this started increasing, and all the different attacks have different facets. So what we observed was that we had a lack of comprehensive and a technology-independent and general description of how these attacks are conducted on the open source software supply chain. So the research question that we wanted to answer are the following. So first of all, we wanted to understand and have a comprehensive list of the general attack vectors on the open source software supply chains that appeared and that we know, so that we can learn from the past attacks. And once we have this comprehensive list, then it's possible to reason and study what are the available and general safeguards addressing the identified attack vectors, and possibly to characterize them with utility and cost. The methodology that we used is the following. So we conducted a systematic literature review of scientific papers and also a gray literature review because, of course, most of this information is available in blog posts, newspaper, and so on, with the aim of collecting all the known attack vectors and the possible associated safeguards to them. The second step was then to model these attack vectors, and we adopted the semantic of attack trees, which are those structures that has an offensive point of view, describing how attackers conduct attacks. And at the root node, we have the general goal of the attacker, and then in the following child nodes, there are refinement of this goal. And finally, we conducted 2 user surveys to assess both the taxonomy and the utility and costs of the safeguards. And these surveys involved 17 experts and 134 developers. So the first result is the taxonomy, and the proposed taxonomy takes the perspective of attackers, so exactly describe how attackers inject malicious code. And the taxonomy was positively assessed by the 17 experts for its correctness and completeness. And talking about numbers, the taxonomy comprises 117 unique attack vectors mapped to 33 unique high-level safeguards. And every attack vectors and safeguard is supported by around 370 scientific and grade literature references. Since there is a huge amount of information and references, we also developed a tool called the Risk Explorer for Software Supply Chain, which is available online and can be interactively used to inspect all this information. So this is a snapshot of the tool, and you can visit it online. Here, I didn't expand the entire tree, also for time constraints. But what I wanted to highlight here is that, of course, at the root node, we have the conduction of software supply chain attacks. And then at the first level, we wanted to describe the different level of the freedom that an attacker can have. So we have the development and advertisement of a malicious package from scratch at the beginning, where the attacker can possibly do everything. Then we have the entire category of attacks that we called creating naming confusion with a legitimate package, because these are malicious packages whose name resemble the one of existing packages. And so, for example, we have typo squatting, combo squatting, and different techniques. And then finally, we have the subversion of a legitimate package. And then further, you can see here that are mapped exactly the systems that were depicted before in the software supply chain model, namely the versioning control system for what concerns the injection of malicious code into the source code of a legitimate package. The build system for what concerns the injection of during the build of a software, and finally the package repository and distribution platform for what concerns the distribution of a malicious version of a legitimate package. You can check the entire explosion of the tree either in the tool or in the paper, or we can discuss it at the coffee corner. For what concerns the safeguards, here and in the paper, we made available the table of all the safeguards ranked or sorted by the highest utility to cost ratio given by the participants to the survey. And at the beginning of this table, we have some safeguards like protect production branches or version pinning that were considered by the experts highly effective and pretty cheap to be implemented. In the middle, one interesting case was the prevention of squatting for packages. And here, the common answer that we received was the fact that it's pretty hard to preventively squat some packages. Sometimes this is employed, but there are some legitimate cases in which some package names resemble other packages. And so this is not a panacea for fixing, unfortunately, the problem of typo squatting. But what was also surprising was what is at the bottom of this table, which is building the packages or the dependencies from sources, which were pretty known to be used in big organizations as a good measure. But this was resulted as pretty costly for the real benefit that this could bring. For the possible use cases of our work and the Risk Explorer tool, we envisioned that it can be used for training and raise awareness of this problem among both practitioner and security experts, but also to non-security experts. It can also help to scope red team activities and to scope penetration testing, having this extensive list of attacks. And if it's true that good security comes with a good threat modeling, we hope that this work can aid in threat modeling activities. And this was also tested internally at SAP, and we received also some feedback from other organizations that was found to be helpful somehow in this task. And for other use cases, I would be really happy to hear your story. So to conclude, our work proposes a taxonomy of open source software supply chain attacks, which is available online, was assessed by experts and developers, and we hope that this can create a central point of references and aid for future research, and that might serve different use cases. For what concerns the safeguards, we mapped high-level safeguards to those attacks, and we conducted also a qualitative assessment of their utility and cost. And we hope that this comprehensive collection of safeguards may help in designing new strategies or frameworks to address and tackle this complex problem like open source software supply chain attacks. So this concludes my talk, and I will be happy to take your question. Thanks.
If you have questions, please stand behind the microphone. So to kick off the conversation, I would like to say that this is a very dense paper. It's SoK, so you do want to read the paper before you can ask meaningful questions, right? So let me ask you a question. So I know you did a lot of interviews with all the people involved in this study. So what are their most significant concerns about the current security landscape?
Well, so first of all, thanks for the very interesting question. Indeed, we engaged with a lot of people, and then even subsequently to this work, we started talking with people. The main concern is that probably there is not a single bulletproof solution for that, as we can observe. It's a really complex problem. There are some experts which thinks and advertise some good direction that we should take, like, for example, reproducible builds that I probably will hear later during this session, and then other strategies. We also started discussing with the OpenSSF about the taxonomy. What we observed was the fact that we started seeing a lot of frameworks coming in the industry and also in these communities. And we hope that with the taxonomy, we can aid in really designing and understanding what type of threats these countermeasures or best practices that are proposed so far can really address. So I think this is mostly the concerns and the possible directions that we would like to take as a community, I would say.
Awesome, thank you. Any other questions? Okay, so if not, I'm going to ask you a second question, which is: Has anyone expressed their concerns about open source project authors selling their packages to third parties, and then the third parties will take the packages over and then potentially inject security impacting code?
Yeah, so I don't know about selling their project, but what I can say that indeed the problem of funding open source is a real problem, and this in fact opened to some real supply chain attacks that happened. For example, if I'm not wrong, was the event stream case, in which there was the project maintainers that was seeking for contributions to the project because all the top companies were using it, and the random guy just jumped in and asked him to give to him the administrative access to the project, and he was happy to give to him and to be helped in that, and this guy then inserted a malicious dependency. So this is what really happened also in some cases, yes.
Awesome. Thank you very much.
Thank you.